So here's a big question. Do you believe God created heaven and earth in only 6 days? Another parallel question. Does modern science contradict this story? Well, if we would draw out what comes from Genesis 1 and other parts of the Bible and try to imagine what they mean, this is the picture we'd wind up with. And why are we so convinced? Well, because the Egyptians and the Mesopotamians, so the two neighboring big civilizations near Israel, they had this cosmology. There are even different drawings of that or other descriptions. So people in that region believe that the earth could be imagined like this. So you have one part of land surrounded by an ocean, and then there's the firmament, which is a rigid dome with the stars screwed in, and with the sun and the moon just like kind of like walking on that dome to go around. Then you can even see windows and doors of heaven. At the beginning of the story of Noah, when the flood starts, there's this idea that God opens those windows and those doors, and then it rains for 40 days and 40 nights. We can see that in the Psalms as well. So God is the one who decides if he's going to send this water, which will replenish the soil and will really help people survive. God decides that. Then what do we see? We see the foundations of the earth. The earth is on pillars, and so that explains the tremors, the earthquakes. That's because the earth is not completely stable; it's on pillars. And then there's the Sheol, which kind of is not exactly hell. It's for the Jews, for the Hebrews. The Sheol is more like a resting place. It's a place where the soul goes and stays, but is not active. We couldn't say it's alive. It's just barely alive. It's still existing. It's still there, but it's like frozen there. It's waiting. And I think I said pretty much everything. Okay, then you have God, which is transcended way above that. And you have the gates of heavens, the heavens of heavens, and there are other apocrypha that talk about, the seven heavens. So God is in seventh heaven, the highest of those. Other creatures live in those, the angels, mostly, and different kinds of angels. So there we go. And Jesus prays our God, our Father who art in heaven. So yeah, that's how Earth is imagined, and I hope this picture will help you in further readings in the Bible to understand what's the geography and the cosmology, the understanding of the cosmos back then. So how come this doesn't work with our modern cosmology? Okay, how we understand the world today? Well, first of all, there's no water above a rigid dome of the sky. We know this because, well, I never took a spaceship. I took a plane a few times, but never a spaceship. So I didn't get the chance to see like the Apollo missions or people from the International Space Station. I don't get that view from the Earth. But as a meteorologist, I have sent one weather balloon that probes the sky. And what that balloon does is it goes up, 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 and the air, it gets thinner as it goes up to finally being so thin that there's no more pressure on the balloon, and poof, it explodes, it bursts, and then the material comes back down. These balloons are sent twice a day. Yeah, so we know there's less pressure up to a point where there isn't any. And also, the reason why the sky is blue is simply because the way the light comes in, the color blue bounces off the molecules. The other colors can just go straight, but the blue bounces off in many directions, and that's why whatever direction you look, there's this bouncing effect, and it comes back to you. It's blue in all directions. But the ancients thought that the sky was blue because this rigid dome was also transparent, and beyond that there was water. Voila. Okay, number 2, second reason why Genesis 1 just is not a scientific story. Life began in the water, not on the continent. So according to the story, life in biblical terms starts on day 4 and then more practically on day 5 but we consider today the trees to be alive, but then anyway, the modern science, we really agree that life began in the water, not on the continent. So we have an example here of blue-green algae. Interesting fact, slowly over 2 billion years, the blue-green algae produced oxygen in our atmosphere by removing the CO2. It's a process called photosynthesis. But that lasted, look how much time, 2 billion years. And we see this gentle increase of oxygen going from practically nothing to 21% now, which gave rise to all the living beings that breathe oxygen. Okay, then the sun and the stars. So when you're in a model where there's a flat Earth and the sun rises and sets and rises and sets, the sun is the one moving, it took a lot of effort and lots of calculations to finally get to what Copernicus figured out, that it was not only simpler but more accurate to draw it like this, with the sun in the middle and the planets are going around, including the Earth. And so then we also understand that the Earth is turning around itself. There's a rotation. So the sun is not physically rising and setting. It's the Earth that's turning. So officially the sun is not rising. It's simply that, oh look, we are now facing the sun. And when the sun is setting, we will now be facing the other side of the sun. We'll be facing the rest of the void. Also interesting thing, the stars are not just random points of light, they are also stars. The stars are suns that are far away. And our sun is a star, which is obviously the closest. Another word on the sun and the stars, and this is a very important point. If the sun arrives on day 4, what was lighting the Earth on days 1, 2, and 3? Now, people say, I've read this, that it was God's light that was shining on Earth. Well, if that's the case, why does God's light stop shining as of day 4? There's this confusion, and it's quite peculiar. So that God creates light is one thing, but then, anyway, there are questions. Genesis 1 does not answer that question. The sun, the earth, and the planets of the solar system were formed 4.5 billion years ago. Okay, that's a little tidbit of information that goes beyond like a 6,000 year young Earth. The moon and the planets. Okay, so here we have Galileo explaining to two cardinals, and he has a telescope right there. Here it is. Galileo was the first to describe the craters of the moon, the moons of Jupiter, the rings of Saturn, and his telescope would be able to zoom 30 times. So he discovered that these spheres in the sky are not perfect spheres, nor moving stars, but planets. The the way to define the word planet changed thanks to Galileo's observations. Before, we'd call a planet just this star going through the sky and moving independently from the other ones that were turning. Planets, there were 5 that people could observe, which represent the days of the week, actually. So there's Tuesday was for Mars, Wednesday was for Mercury, Thursday was for Jupiter, Friday for Venus, and Saturday for Saturn. And in some languages, it's actually easier to correspond. Okay. Let's continue. Land species. Land species came before air species. So the reptiles came before the birds. But the story from Genesis 1 shows that on day 5 you have the animals of the air and the animals in water, and then the animals of land only come after. But that's not what we observe in evolution. That's not what we understand. The fish first, then some weird type of fish. Through evolution, we get amphibians who are now able to walk on land. Then they specialize and we're not dependent of water anymore, so we get the lizards. And finally, we get land animals, and through those, some types of reptiles were able to fly, gives us the birds we see today. So it's that sequence from the sea to the land and then to the air. Okay, fish to reptiles to birds. In Genesis 1, fish and birds are created on day 5, reptiles on day 6. There you go. Yet birds come after reptiles. So why am I talking about the science? Well, simply because most Christian traditions, including the Catholics, have a respect for all the research that's been done besides, because these are fellow human beings making observations and coming to conclusions thanks to those observations. When we don't know in science, usually we're very humble about it. But when we do know, well, we share it as a fact, unless we are able to disprove that fact with something else to update. So Galileo was actually the first to make this an academy of sciences. But the Inquisition kind of stopped what he was doing. But one of Galileo's good friends was Pope Urban VIII. So there was this link with the Vatican. Finally, it was stopped very quickly, and it was revived at the end of the 19th century, and is now called the Pontifical Academy of Sciences. This is on Vatican grounds. People work there. They coordinate a bunch of efforts of dialogue between science and religion. And there's at least one, you could call it symposium, or one meeting of top grade scientists from different fields once every year. So what do we know? What's the modern cosmogony? Okay, you see the word cosmos there, so the universe, but goni here is kind of like Genesis. It has to do with the origins of. Okay, so what do we say in science textbooks about the origins of the cosmos? Well, there's evolution of the universe. That's been going on for 13.8 billion years. Then we focus on the Earth. That's an evolution that spans 4.5 billion years. Just by the way, it's the evolution of the Earth, but the whole solar system as a whole. And also the evolution of life, which to be interesting is 600 million years. I'll get back to that in a moment. So we can start with the evolution of the universe, 13.8 billion years. It starts with the Big Bang. Now, what's really interesting is that a few decades ago, we would have asked Einstein, when did the universe begin? And Einstein would answer, there was no beginning. Einstein believed that the universe was just infinite, and there's no beginning. And there was also kind of this competition between science and religion. So the story from Genesis was actually stopping some scientists from accepting that there could have been a beginning. But lots of scientists kept on making observations and looking at the data. And there's a Catholic priest called Monsieur Le Maître, and he made observations, and he came up with the theory of the Big Bang. He didn't coin the phrase, though. His opponents coined that expression, Big Bang, to laugh at him, saying, oh, it's like a Big Bang. But no, he had another expression for it. Fast expansion, rapid expansion, I believe. And so you have this moment where time and space began, and a very rapid expansion, and then it keeps on expanding, but much slower than what it was compared to the beginning. Why do we come to this conclusion? Well, simply because we've been observing in all directions, all the stars, and they all seem to be getting away from us. So, kind of like raisin bread, and so as it cooks, the raisin bread gets bigger, so all of those raisins are going farther apart. So that's what's happening to our universe right now. It's expanding. So if our observations lead us to conclude that they're expanding, well then, logically, it means that they used to be closer together, and you can try to calculate at which point everything was converged together. So there we go. Then we can focus on the solar system and one really interesting planet, ours, planet Earth. And then you get lots of phases of the Earth. There are many more to those. This is just a quick flashback. So when the Earth formed, there was all of these rocks coming together and finally squished together, and all of the gravity squishing together makes it really, really hot, and that's where we get the hot magma. And then at the beginning of the Earth, it wasn't exactly round, and then lots of lava trying to spill through and trying to make it and even it out. So that's why even in the time of the dinosaurs we show these lots of volcanic eruptions, because there were lots of those. So the first picture on the left, you see billions and billions of years ago. That's what the Earth looked like when the crust finally cooled. Wasn't so magma liquid, but finally was cooler. And then the rest cooled a bit more. Then the first types of precipitation came down. Was acid first, but then finally you get to water, and then that filled the first lakes and first oceans. And it just kept on cooling and cooling and cooling. At a certain point, there was one ice age that was so cold, we call it the snowball Earth. That's the second picture. And then we went in a glaciation period, and then hotter and cooler and hotter and cooler. We're talking millions of years here. And we finally get to the dinosaur era, which lasted up until 65 million years ago, when a meteorite smashed into the Earth. The dinosaur one actually smashed near the Yucatan Peninsula and blew out from the Earth's crust so much, so much dust into the atmosphere, spreading all across the atmosphere, that it blocked the sun, and so the vegetation could not grow, and it was cooling everywhere, so the dinosaurs disappeared. And from there, the little mammals, kind of like mice, were able to survive, and then that led the mammals to thrive after the dinosaurs. 12,000 years ago, the last ice age, we were coming out of it, and humans had already populated all around the Earth, and that leads us to present day with the continents the way they are. Oh, for the dinosaur era, one cool fact. We consider that the continents were much closer together, so there was like one big ocean and one big continent on one side. The tectonic plates hadn't spread out that much yet. So we're talking about Pangea. And so one big continent. And we see proof of this from dinosaur fossils. We have exactly the same species of dinosaur fossils in South America and in Africa. Exactly the same species. And that's because they were part of the same continent. And then that split open and they spread apart with time. But back then, that was part of the same continent. Wow. So that was the evolution of the Earth. And then we focus on living things on Earth. Now, we think the first signs of life on Earth 3.8 billion years ago. And then the blue-green algae, that's around 3 million years ago. 3 billion, sorry. And the blue-green algae produced the oxygen we have in our atmosphere, and that gave rise to other living things that could use the oxygen, so that was obviously extremely useful. And then it's around 600 million years ago that there's the beginning of multicellular life on Earth. Why is it more interesting? Why do I put that as the beginning of evolution of life? Well, simply because when you have multicellular life, the different cells start playing different roles. So they differentiate. So now you start having rise to different organs. And then evolution becomes really interesting because those organs can change their role as it goes along. Now, there are lots of reasons why we get to the conclusion that evolution is how life diversified on Earth. I see a certain kinship with the bony fish, the fish that have bones, and myself. We both have, rough number, around 200 bones. And obviously it's the same thing if we look at dinosaur bones or whale bones or giraffes or birds or name all of the vertebrates. We all have around 200 bones. But the bony fish don't have ears. They have ribs, and they would have 15 pair of ribs. Do you know how many pair of ribs we have? 12. So why is there a difference of 3? They don't have ears. They don't hear. But as we look at evolution, how things changed, those 3 top ribs, they migrated and gave us the 3 bones we have in our ear structure. If you look at the way our hands are made with 5, and then you look at the wings from birds that also have these 5, it's just amazing. And we have so much in common. So we have like the same basis for structure, but then we have this diversification. This is one way to represent that diversification. You're going to look at it and think it's complicated. It kind of is. But it shows how life has just gone in every direction. Here's another one which I find really interesting. You have the origins of the Earth right in the middle there. It says Earth birth. And then we go in on the left, and we see first types of life which were bacteria. And then you get the plants and the algae, obviously, and then the fungi, and that diversifies, and then the echinoderms, the fish, the amphibians, the reptiles. From reptiles we get birds. From reptiles as well, all of a sudden they get furry and warm-blooded. Those are the mammals, and that diversifies a lot. And you can also see dotted lines. Those are the mass extinctions. Okay, so there were 5 major mass extinctions. The last one was 65 million years ago when we lost the dinosaurs. So wow, I'm just amazed, and that's what we know just by research and digging and making a bunch of being curious. Human beings are curious, and we can make this research and discover all of this. People who would look at the Earth's history, and then people who would look at the evolution of animals, and others would look at evolution of plants. Other geologists would look at the meteor impacts. Everyone was working in silos. And one day, a group of people thought, hey, let's put all of this on the same poster. And so that's how we get a correlated history of the Earth. And that's how they found that during the big mass extinctions, it's usually because of a big meteorite impact. We see on the left the tectonic plates that change with time. We see plant evolution and animal evolution, really quite amazing. And that's been a good tool for me to understand. If ever you want to learn more, in a nutshell, about universe evolution, the Earth's evolution, and finally evolution of life on Earth, the book Origins, that was written by Hubert Reeves and also 3 other magnificent people who could help more with the biology of it, make up this great story. It's a little book. It's easy to understand. And, you know, if we want to understand our origins, that one's great. If you're more interested in how the universe itself evolved, a briefer history of time from Stephen Hawking really does the trick. But then it's just a universe. We don't get evolution of life. Finally, there's this award-winning documentary called Journey of the Universe, which looks at what I've been talking about previously, but also asks the existential questions that go with them. And I think this is a movie that lots of people have to watch. I think this is a movie that we can sit down and watch as a church group and just be amazed of where we come from. And still, like the ancients, keep on searching for God's place and our place related to all of this created universe. So, we went from a flat earth with a rigid dome and water on top to a blue marble hanging in the black of space, and this is our home that we have to take care of. The story of creation in 7 days does not describe how our natural environment was created. It describes why. So after acknowledging all of the scientific discoveries and how we understand the world today, which the Bible does not do, but it does help us a lot with these existential questions.